Hi, my name is Sean Aziz, and today I'll be giving you an introduction to creating test cases. Before we can create a test case, we must first understand the requirements validation lifecycle. There's basically 5 components: requirements, scenarios, test cases, test set, and test script. A requirement's created, a test case is generated from that requirement, and that test case is used to validate the requirement. So let's take a look at requirements. What is a requirement? Well, a requirement is basically a behavior or functionality that is expected in a system. Meaning the business says we have a new system coming down the line, or we're doing some modifications to our existing system, and we have a certain functionality that we like on that system. We like that system to be able to perform. A requirement can either be high level or it can be extremely detailed. The more detailed the requirement, the easier it is to test. Well, actually, that statement isn't quite true. Scratch that statement. Let's say the more detailed the requirement, the more effective you are in testing or creating a test case to validate that requirement. Okay? So again, the more detailed the requirement, the more effective you'll be in creating a test case that can validate that requirement. There are 3 phases to requirements analysis. There are 3 stages to any requirement. It's called requirements analysis. There's eliciting requirements, there's analyzing requirements, there's recording requirements. Let's see if we can break those down. Now let's start with eliciting requirements. Okay? What is eliciting requirements, or also called requirements gathering? The task of identifying different types of requirements from various sources. Sources can be project documentation, project charter, business process document, stakeholder interviews, things like that. A lot of it in the entry level, we'll call it. So eliciting requirements is also called, or normally used as, requirements gathering. Analyzing requirements. To analyze requirements, it's determining whether the stated requirements are clear, complete, consistent, unambiguous, and resolving any apparent conflicts. So the business says the new system's coming down the line, and we jotted down some information on the back of a napkin, functionality that we want the system to have. We'll call it our requirement. What we want to do as a BA is validate that requirement that we've been given, making sure it's clear, complete, consistent, unambiguous, and resolving any apparent conflicts. Basically, we want to make sure if that requirement is true and we've examined it enough. Okay. The third part is recording requirements. Now, in layman's terms, recording requirements is basically documenting the requirement, and there's various types of ways you can document it. You can write it on the back of a napkin. You can use natural language documents such as Word to create any type of a document. You can use use cases or user stories, process specifications, so something more methodical to your documentation creating. Okay? So scenario. Let's take a look at what a scenario is. So a scenario basically is any condition that can possibly happen when the requirement is being executed. Any condition that can possibly happen when that requirement is being executed. Here's an example. The business says we have a requirement, an online requirement of canceling an order. We want to have a cancel order ability on our online or some type of IP. So with cancel orders, there's different types of cancel order. There's a cancel order that maybe the order doesn't exist, or cancel order maybe the order is not refundable. Maybe the order has already been canceled and you're trying to cancel it again. So these are all different tests you might want to perform to validate the requirement of cancel order. Note for the for the requirement cancel order, we have many scenarios, so that one requirement will have multiple scenarios. So if we're going to look at the relationship between a requirement and scenario, we'll know that there's a one-to-many relationship between a requirement and scenario. Also, it's important to try to get every possible scenario for that requirement. It makes it easier to validate the requirement after the fact. Okay? So what we're going to do is take a look at test cases. Okay? Basically, there's 5 stages. There's basically 3 stages to a test case. But to better explain it, I've made 5 possible components to this test case. Okay? So the component to the test case I have is input, precondition, test execution, postcondition, and result. So an input can be any type of value, such as an order number. Precondition is setting up the environment before the actual test you want to perform. The test execution is the series of steps performed in the actual test case. The postcondition is some things that would happen after you ran your test, tables being updated, things like that. And a result, meaning that after the postcondition, we validated all the conditions on the postcondition, and we'll give a Boolean expression, a true or false, to say whether the test case is passed. Okay? So if we were to create a simple test case for, again, cancel order, we might have order number referred to as input. We might have a precondition, things that have been created before the test can be run, a series of steps that have to be performed in executing the test case, our postcondition, and again our yes or no to see if the test is passed. Okay, if we expand precondition a little bit, then things that we might want to set up in the environment is the order was created with a credit card, the order status has to be refundable, and the order before we run our test case should not have been canceled. Okay, maybe even the order has not been shipped. Okay. What we want to do then after executing the test case is validate our postconditions. Postcondition can be, did we validate if the order was canceled? Was it canceled? Was the credit card refunded, and was it refunded with the correct amount? Was our inventory adjusted, and was that adjusted to reflect this canceled order? Now, I have a simple formula for test cases, and that's input plus precondition equals postcondition. Pretty simple. Now, if we change the input slightly, and you add that to the precondition, it actually changes the test case itself. So if we change our input slightly, or we change our precondition slightly, we'd actually change our physical test case. Okay, we can now create multiple test cases, or a larger number of test cases for any given scenario, just because we change our input or our precondition. Negative test case. So most companies use negative testing in actual. For every scenario, they would not only have a positive test case, they would have a negative test case. And basically, a negative test is if you run the test and the test fails, that means you have a positive result and you can pass your test case. So if the test fails, the test case can now be passed. An example, in most companies that don't normally run negative tests all the time, they probably use a negative test in scenarios where you want to validate if, let's say for instance here, I'll give an example. American Express. American Express has a 4-digit CSV. That 4-digit CSV, you want to validate the input box to make sure that it doesn't accept things like a 3-digit number, or you want to validate that it doesn't accept any alpha characters, okay? That it only accepts a numeric value. So you'd run a negative test case, and if you type in 3 digits into the input box, your expected result should be that it should fail and give you some type of warning message saying, it should be 4 digits or whatever the case is. Okay? So, just to recap quickly, a test case is created for the various scenarios. You can have, at least 2 test cases if you run a negative test case for every scenario. Test cases are made up of input, precondition, the actual test execution, a postcondition, and the result of that postcondition. Okay? A test set. So a test set is basically grouping together test cases. So you'd have similar test cases that can be grouped together, and you would bundle them into what's called a test set. So what I like to use is an example of the cancel order. Although there's different types of cancel order, they can all be classed under the cancel order umbrella. Okay? So a group of test cases that require the same steps to be executed is called a test step. A group of test cases that require the same steps to be executed is called a test set. Okay? So the relationship between a test case and a test set is a many-to-one. There's many test cases in one test set. Okay? A test script. So basically a test script is a set of steps or actions needed to execute your test case, or a group of test cases that are similar, meaning our test set. Your test script can be manual or it can be automated. Creating test cases. What happens if someone asks us to test a simple condition? Okay, so there's a requirement and we have to create test cases for this requirement. So in our simple condition here, we have an input box that needs to be validated, and if the value keyed into that input box is greater than 50, then we want to store that value. Okay? So again, if the value in the input box is greater than 50, we want to then store that value. So before we decide to create test cases, the first thing we're going to want to do is try to ask questions and validate. So do we have to validate the value of the input, that it's only numbers and not letters or alpha characters? Do we want to validate if there is boundary testing? So if x is equal to 50 as well as greater than 50, storing x, is it going to be stored on a database somewhere? Is it going to be stored to a local file? Is it going to be stored to a database that's outside of our network? Things like that. So what we want to do basically is, before creating the test cases, is we want to ask questions. We want to find out where in the test cycle are we going to be testing. Are we going to be doing in the early stages? Are we going to be doing white box testing to help out the developers? Are we going to be doing some type of functional tests or UAT tests or black box testing? Is the product getting prepped up for market? Is this condition or this input box, is it on a server? Is the server clustered? Is the input box exposed? Do we have to test whether the inputs are sanitized? We don't want to cause any exposure to the company, so you want to validate that. Again, where is X being stored? So the key is to ask questions, not just create the test cases, but to ask questions. That way you can create proper test cases, valid test cases that are more effective to be able to validate the requirement. Okay, so your test cases. They'll be different depending on where in your testing life cycle you're testing. In a clustered environment, you may want to test load balancing, or you may even want to do some load testing. You want to, validate if the component is outside of a firewall, or any firewall rules have to be created for it. If it's outside of the black network, if that's the case, and firewall rules have to be made, and this is supposed to have some type of aggressive timelines for testing, then you want to take that into consideration when creating your test cases. Because I'm pretty sure getting firewall changes created, it's not something that's swift, and it takes some time. So it may slow down your process. You may have to defer some test cases because of this, or you may have to withdraw, those requirements completely. Nevertheless, it's better to be prepared. So ask the questions. Creating test cases are easy. It's gathering all the right information for those test cases. That's the hard part. Gathering all the right information for those test cases. That's the hard part. Here's a sample spreadsheet, Excel, for test cases. Now, normally, your test suite would have inputs that you can import directly from various Excel documents or other type of text-based documents. So whether you're dealing with any type of rational software, or you're dealing with some type of quality center, they would have these simple inputs. But for our example, we're using a simple system that only has test cases created on Excel. So what we've done is we've grouped our test cases, and we've grouped it based on, requirement. And in this requirement, it's our cancel order requirement. We've also grouped it based on where the order is from. Could be AR. So this order, this test case was from a requirement called 10-1605 IVR testing, and this is validation on the AR side. It could be validation on a billing side, or some other type of system, or some other type of application. Basically, when I create test cases, I create mine with the task name to also drive back to the requirement it's coming from. In this scenario, our input is also our precondition, making it a very simple spreadsheet. Our process is the steps taken for creating our physical test execution. So, these are the steps that you want to perform when running this test. And then we'll have our expected results. After we run our test, we'll need to validate. And these are some of the post conditions that would exist that we have to validate. And if all these post conditions are true, then we might be able to pass the test case. Or if some of these post conditions weren't true and weren't validated correctly, then we may have to fail that test case. If we fail the test case, then a defect would have to be created. And what I normally suggest when you're creating that defect is to use, again, in some type of message body or a part of your defect title, if you can, the actual test case that it belongs to, and driving it back to the requirement that this belongs to. That way it's easier to look at the defect, even if it's an arbitrary number, and you can look at the description and you can see the test case which this has derived from. It makes it easier to have that synchronization between your requirement test case and your defect. Okay, making it easier to actually resolve defects or help in the resolution of defects. So what I've done is actually I've put a little comic strip here, and it always makes me chuckle when whenever I read this comic strip. I mentioned briefly in regards to the sanitized inputs, and here's a comic strip. It has the school calling a mother, and it says, "Hi, this is your son's school. We're having some computer trouble." And the mom says, "Oh dear, did he break something?" And the school says, "In a way." The school says, "Did you really name your son Robert Drop Table Students? Semicolon." So the mother says, "Oh yes, little Bobby Tables we call him." And the school says, "Well, we've lost this year's student records. I hope you're happy." And the mother says, "I hope you've learned to sanitize your database inputs." So when they were typing that in, I could only picture someone typing this in, the student's name and this long, and they hit the enter button, and that drives right back to the DB, and and truncates that table, that student's table, and and losing all their data. So I mean, this is it's amusing. We can laugh about this, but exposure to the company is the point I wanted to bring up. At any given time, as a tester, you want to identify if there's any possibility for that company to have any type of exposure. So whether unsanitized inputs on an input box, or any type of security risk that we're going to see, even sharing an ID, things like that, we shouldn't do. There should be accountability across the board. Security should be number one. Preventing exposure to your company is number one as a tester. Okay? Well, I hope you enjoyed this session, and happy testing. Take care.